Why is the sky blue? It's all about light being scattered by the nitrogen and oxygen molecules that make up most of the air. Let me explain scattering. Consider sound from forks. When set into vibration, sound is sent all directions. Sound from one tuning fork may even set another into vibration. We can think of sound as being scattered from the vibrating forks. A similar process occurs with the scattering of light from atoms and molecules in the atmosphere. These particles emit light most strongly in the ultraviolet region. So we can say that they have natural frequencies that are greater than the frequencies of visible light. This means that blue light will be closer in frequency than red to the natural frequencies of the atoms and molecules and will be scattered more strongly than red light. You can think of a molecule on the air as a tiny bell that rings at high frequency but can be activated to vibrate weakly at a lower frequency. Like sound from tuning fork or bells, light striking the molecules is re-emitted in all directions. Light is scattered. So of the visible frequencies of sunlight, violet is scattered the most by molecule of nitrogen and oxygen in the atmosphere, followed in order by blue, green, yellow, orange and red. Red is scattered only a tenth as much as violet. Although violet light is scattered more than blue, our eyes are not very sensitive to violet light, therefore the blue scattered light is what predominates in our vision, and we see a blue sky. Where the atmosphere contains a lot of dust and other particles larger than individual molecules, light of the lower frequencies is strongly scattered. This makes the sky less blue and it takes on whitish appearance after a heavy rainstorm. When the dust particles have been washed away, the sky becomes a deeper blue. When I was in elementary school, I remember my art teacher Miss Agnes telling us to color distant mountains blue, for it's true, if you look at distant dark mountains they appear blue. Miss Agnes didn't tell us why. She wasn't into physics. It so happens that the source of the blueness is the color of the low-altitude sky between you and the mountains. You don't notice the blue, which is rather faint, unless it's against a dark background. When we look up at the sky we see it blue, but that's because of the darkness of space beyond. Astronauts above looking down through the same atmosphere don't see the faint blue sky. They see the bright Earth's surface. The brightness of Earth overwhelms the faint blue atmosphere. Note, the thin blue atmosphere at the edge of our planet, visible only because of the dark space behind. Its thinness makes it easy to understand that polluting it's serious business. The atmosphere is certainly not infinite as some uneducated people think. In fact, if the atmosphere were condensed to a liquid, it would be about 12 meters deep, not kilometers. What if distant mountains that are not dark, one of bright snow-covered mountains, it turns out they appear yellowish? Can you figure why? What happens to the bright reflected white light from snow as it travels from the mountains to us? Part of it scatters, mostly the blue part. What reaches us is weak in the high frequencies and strong in the low frequencies, hence it is yellowish. Snow-covered mountains, much farther away, appear even more yellow and even orange. What about sunrises and sunsets? Why are they changed with reds and oranges? Because the low-frequency colors red and orange are the least scattered by the atmosphere. These colors are better transmitted through the air. Red, which is scattered the least and is therefore transmitted the most, is what you see when you look at the sun through the thickest stretch of air, so the thick of the atmosphere through which a beam of sunlight travels, the more high frequency light gets scattered out of the beam. The light that best makes it through a thick atmosphere is that of the low-frequency reds and oranges. We can see that sunlight travels through more atmosphere at sunset than at noon, and that accounts for the variety of spectacularly colored sunsets. The combinations of resulting colors vary with atmospheric conditions, which change from day to day, giving us a variety of sunset to enjoy.